Hello friends. So today we are just going for our next concept in the mechanical properties and their testing. So in the last lecture we have seen about the tensile test and the various types of stress strain curve and the importance of the stress strain curve. Now tensile test, it is just carried out to determine the sum of the properties of the material. There are the various tests are there which are carried out to determine the properties of the material. Now today we will just go with the next test, that is the compression test. So the outline of the today's lecture is the compression test, then what is the purpose of the compression test, then the applications where this test is carried out, then the limitations of compression test, the test specimen, how the test specimen it is there, then the procedure of the test and the types of the fractures. Then we will see how exactly that test has been carried out. So basically the compressive test is comes under the destructive testing. So these are the some sort of that diagrams which shows the electromechanical universal testing machine. So basically the UTM is carried out to conduct the compressive test, or there is some separate compressive testing machine is there which is used to determine the compressive strength of the concrete also. So basically the capacity of these UTMs are varies from 2 kilonewton. This is the lowest capacity and the highest capacity is 1000 kilonewton. So according to that machines are varies. If the test is very precise, then we will go with the lowest kind of that machine, that is the 2 kilonewton for the precious applications or precious material. But in case of 1000 kilonewton, basically the error percentage is more. If the error percentage is 1%, it means almost the error will be generated in the reading of 10 kilonewton. It will be the chance. So this is basically the diagram, schematic diagram of compressive testing machine. In the latter part, we are just going to, or I will just show you how the exactly that compressive test is carried out in the lab. So this is the diagram. Here you can be able to observe in this particular diagram, this is this component in which we want to determine the compressive strength of this particular component. This is the UTM, where this is the lower jaw and this is the upper jaw. So in this particular portion, the upper jaw is applying all those forces. So theoretically the compressive test is merely the opposite of the tension test. So here we can be able to see that in the tension test the two equal and opposite forces are applied, but here exactly the opposite case is there in case of compressive strength. So the forces are acting towards each other. So here we can be able to see this particular force is acting on the downward and the equal and opposite reaction is generated from the bottom end. So these two forces are applying towards each other. So the compressive test can be done on the same machine on which the tension test is done, like the universal testing machine or some other machines which is designed specifically for the purpose that already I have mentioned. Either we can be able to go with the UTM or there is separate CTM machine is there. CTM in the sense compressive testing machine. So in general the brittle materials are good in a compression than the tension. So whatever the brittle materials are there, we have seen which are the brittle materials are there. So basically the glass, concrete, all those materials are comes under the brittle, and those materials are having the good compressive strength than that of tension test. So therefore they are used for the compressive load. Due to this, the compression test is mainly used to test the brittle materials such as cast iron, concrete, stone, bricks and ceramic products. So during the test, the fracture occurs in a brittle material, and therefore the ultimate strength is determined corresponding to the fracture point, and no fracture occurs for the ductile materials. So basically, whatever the fractures are there, in case of ductile material, there will be no any fracture. So there is different kind of that failure pattern. But in case of brittle material, we will get the fracture, and those patterns we will again see in the next part of the slide. So this is basically the schematic arrangement and the nomenclature in the compressive testing machine. So this is the movable head. Here, that is the specimen. It will be a rectangular, it will be a circular. So the concrete, whatever the column is there, so basically it is made up of with the two shapes. Either it will be a rectangular shape or it may be a circular shape. So basically the speed of the machine testing is 0.05 minutes. So this will be the direction of the load, that is at the bottom, and equal and opposite reaction will be generated from this bottom end, and this is the fixed head. So this is just a general schematic part for the compressive test. Now the purpose of the test. Here we can be able to see it is very interesting. Here I want to show you how that exactly the compressive test is carried out, and this kind of that pattern of failure may be generated. So basically for the ductile material, this particular portion has been buckled over here. So here we can be able to see this is the specimen. These are the two upper heads and this is the lower head. Okay, and the forces are applied. So equal and opposite force will be generated according to the Newton's third law of motion. So this particular component has been buckled like this. So if it is extended, that load has been extended further, this kind of the deformation is observed. Now why the compression test is carried out? So the goal of the compressive test is to determine the behavior or response of the material while it experiences a compressive load by measuring the fundamental variables. So basically this is the first purpose, that is the response of material under the compressive load, that has to be measured the fundamental variables. So the mechanical properties like compressive strength, yield point, elastic modulus and stress strain curve may also be determined from the compressive test. So whatever the properties we can be able to determine through the tensile test, those properties again we can be able to determine by conducting the compressive test. With the understanding of this different parameters and the values associated with the specific material, it may be determined whether or not the material is suited for a specific application, or if it will be fail under the specific stress. So basically we have to determine the application where we want to use that particular material, and by conducting the compressive test we can be able to determine, so this particular material can be able to suited for a certain application, it can be able to sustain under that particular load or that particular stress or not, that we can be able to determine through the compressive test. So this test procedure offers the possibility to test a brittle and non-ductile metals that fracture at low strain and avoid the complications arising out of necking. So there will be no any necking and low likewise portions will be generated like a tensile test, but basically the most of the brittle materials we are just conducting the compressive test. So these are some applications where we need to conduct the compressive test, because these are the industries where the many more applications are there which are undergone the compressive loading conditions. So aerospace and automotive industry, then construction industry, cosmetic industry, electric and electronic industry, mechanical device industry, sorry, that medical device industry, then packaging industry, paper and board industry, plastic rubber elastomers, safety, health, fitness industry. So by basically these are the very general applications. So everywhere we need to conduct the compressive test. So the compression testing is usually easier to conduct than the tension test. Is it is used mostly common to at the elevated temperature in plasticity or formability studies, since it simulates the compressive test stress as it expected under the rolling forging and extrusion. So basically the compressive test to conduct it is very easier than that of the tensile test. So these are the limitations of the compressive test. So the friction between the machine head and the sample affecting the result, which causing the stress to have the small inclination. So basically if here we can be able to see in the figure 1. So if suppose the component has been deviated, the center has been deviated, if the loading condition is somewhat deviated from its center, might be some sort of that different kind of that buckling portion we can be able to observe. So the top and bottom faces of the specimen are perfectly parallel to each other, and there is always tendency for bending of the specimen during the testing. So during the testing there are chances that that particular component maybe gets bent. So this is the related to the eccentricity may cause the instability, which is shown in the figure 1. So that eccentricity, if some sort of that force has been deviated from its center, that eccentric portion may cause the deviation. So for a certain metallic materials, the buckling and barreling, the complicated testing can be minimized by the designing the samples as per the specifications and using the proper lubrications. So long samples are prone to be buckled, therefore the length of the specimen must be limited. So this is the long portion here we can be able to observe, and which is having the tendency to gets buckled. So we have to avoid the long specimens. And again, a small samples results in an inaccuracy in a result using the large samples required for testing machines with a large capacity. If the capacity is larger and if the component is very smaller, again it will produce the inaccurate result. So these are the limitations for the compressive test. So the test specimen, these are the test specimens. Here we can be able to see the test specimen. So it is generally either a cubical or cylindrical. So according to the ASTM standard, we have to manufacture the test specimen with a cylindrical portion, and according to the Egyptian standard we have to manufacture the specimen rectangular. So these are the some sort of for the concrete purpose. So these are the various standards. American standard is different, Egyptian standard is different. So these are the portions. Now what is the exact procedure to conduct the compressive test? So bearing blocks are used to ensure the load is applied to the specimen. So some sort of a bearing blocks loading, that is the loading blocks has been used over here just to ensure how we can be able to apply the load on that particular component. Then spherical loading heads. So these are the spherical loading heads we are using just to apply the load. So by the red color we can be able to see over that. So it is just avoid to apply the load at the single point. So because of the spherical loading heads, we can be able to avoid the loads at the specific point. So cylindrical specimens are preferred to ensure the uniform distribution of the stress. Three types of the specimens are used. So basically these are the three types of the specimen, where the long specimen in which the length is 8 to 10 times of the diameter, the medium specimen in which length is equal to 3D, and the short specimen in which the length is equal to almost the diameter of the specimen. So the test metals used for the bearing, since the fraction induced in the testing will be reassemble the bearing condition. So these are the conditions of the compressive test. Now this is the fracture pattern. So the break and fracture here we can be able to observe. So this is the brittle failure. So basically in case of the brittle material, these kind of that fracture pattern we can be able to observe, and this is the semi-plastic. So in the semi-plastic minor fractures we can be able to observe, and for the plastic or any kind of that ductile material, this kind of that failure may be occurred. So that component has been gets buckled. There is no any fracture are appeared on the component. So this is the for the ductile material how that particular graph has been varied. We can be able to see over here. So these are the some sort of the loading conditions and the exact part of the breaking and fracture. So for the semi-ductile and for the brittle, how the portions are there or how the diagrams are there. So for the semi-ductile, again that graph here we can be able to see how that graph will be there, and for the brittle material how the graph will be there, and how that fraction pattern for the brittle material that we can be able to see over here. So exactly along the plane we are getting the fracture. So that cleavage line here we can be able to see that cleavage line, and basically that fracture is occurred in case of brittle material. So these are the for the fixed end how the fracture is there. So one frictionless end and two frictionless end. So these are the some sort of that fractures. So how that concrete failure is there for the different shape that is shown over here. So for the cone shape it is likewise. So for cone and split it is likewise. When the cone and shear is there, so this will be the fracture portion. When the shear failure is there, this will be the fracture portion. And when the columnar is there, so this will be a fraction portion. So these are the two videos which I want to show you how that exactly the compressive test is carried out. So just see carefully how the exactly the compression test is carried out. So this is the animated diagram. So this is the specimen. Okay, so basically the specimen is of the ductile material. The machine capacity is of 200 kilonewton. So which can be able to apply the load of 200 kilonewton maximum. And this is the portion. So exactly we want to set that particular component under the perfect loading condition. So it should not be deviate from the center, and this is how the stress strain diagram is formed on that particular laptop we can be able to observe. So this is the animated the testing under the lab how it is carried out. So the load is gradually applied over here, and here we can be able to observe. So this is just carried out for the ductile material how that portion of the failure it is there that we can be able to see in that video. So this is the transfer that displacement, okay, and this will be a force. So force versus displacement curve it is there, and this is the diagram for the steel it is the ductile material, and we are going to observe how the failure pattern of the ductile material it is there. So basically these are the nomenclature. So one is the test specimen and all. So this is the realistic machine of the compressive test and how exactly the specimen has been set. So every time it is not needed to apply the forces vertically, sometimes we need to conduct the test in the diagonal plane where the diameter is there. So in that manner that component has been set, and then the load has been applied to that particular components. So here we can be able to see that those component has been set, then reset the machines, and then we need to apply the timer. So those particular electronic panel gives you the reading about the timing and the loading conditions. Then we need to start the machine, and then exactly the load has been applied on that particular diametric plane. So this is the one way to carry out the compressive testing. Now the load is gradually applied on that particular components. Here that constant loading is goes on. We can be able to see on that panel also how that load has been. Now that particular timer has been set to the 0. We have to stop the machine, and then we can be able to observe how the failure pattern is there. So that has been just set under some sort of that compression. So we are just here setting that particular uh, column exactly under that particular machine. Then now it has been set for the compressive test. So in that particular machine, in the first machine, what we have seen, that is we are just setting the columns under for the compressive load. Now how exactly here on that panel we can be able to see the load and all those conditions. So this is the local language which has been set. Now how that exactly the testing has been carried out for the concrete, we can be able to see. Now the load is applying on that exactly on that particular component. Here we can be able to see the displacement of that particular component. As well as here in this particular panel the loading, and this will be gives us a displacement. So this will be the graph. So how that exactly the failure has been occurred here in this particular diagram, we can be able to see this is the fracture and this will be the fracture portion on that particular concrete. So this is the real condition. Now that graph has been dropped. So in the slow motion we can be able to observe how that fracture has been occurred. So directly we can be able to see over here. This is the fracture portion. So in this way the compressive test has been carried out. So here we can be able to observe suddenly that particular graph has been dropped once the fracture point is occurred. So this is the realistic compressive test. I hope you have enjoyed this particular lecture. In the next lecture we will just go with the remaining tests. Thank you very much for patience listening.